Good morning, good afternoon, and good evening. Welcome to the holiday edition of Demo Tuesday. My name is Mike, and I'm a technical product marketing manager at Forward Networks. Today, I am joined by one of our esteemed customer success engineers, Jack Shen, and we're going to go through something that we have gotten questions asked upon us at the last few conferences that we've been in. So I've had both network security guys, cybersecurity guys, and a couple of network guys ask me, is there an easy way for us to find rogue devices inside of our inside of our platform? So I'm going to ask Jack that question. First off, Jack, welcome to Demo Tuesday.
Oh, thank you for having me.
Awesome. So with that, Jack, is there an easy way inside of the Forward platform to be able to find and recognize and potentially even alert on rogue devices?
That's a very good question. So you're looking for devices in your network that you're not expecting to be on there. Is
Correct.
that a good way to summarize it? Well, let me
Correct.
show you. So here we go.
Oh,
This,
what am I looking at? What is this in
well,
Forward
this
app?
doesn't seem like too much right now, right? You got a blank page over here. You got some text over here. This is the for NQE library. And let me tell you
Hmm.
a bit about NQE first, right? So NQE, in my humble opinion, is one of the most useful feature in Forward Enterprise. So the way it works is that when Forward collects data from your network, we're collecting a lot of information that may or may not be useful to you. And NQE is a way to filter out the not useful information and giving you only the useful information by using a database language. So NQE stands for Network Query Engine, and we're going to use NQE to filter out all the devices in your network and look for only the rogue devices. Does that?
Interest
Yeah.
Interesting. So if I wanted to find, so say I was a organization that's heavily audited and we don't want to run or we don't want any like Huawei devices inside of our like
Uh,
environment.
mhm.
That's like easy to do with, this
Yeah,
query
yeah. Let's
language.
think about this, right? So we're collecting a lot of information from all the devices, and one of
Mhm.
the information we are collecting is ARP table. In ARP
Okay.
table, there are two pieces of information we're looking at, right? The IP address and the MAC address.
Hmm.
So if you're looking for Huawei devices in your network, what we can do is look at the MAC address of your ARP tables and look for if the OUI vendors are identifying that MAC address as a Huawei device.
Okay.
Now, that will get you a little closer to where you're looking for. From there, you can log into the device using the IP address that we identify, or you can simply say, well, that device is a rogue device. Let's shut off the interface in which we learned that device on.
Oh, so
So
we can get all that. So we can get all that like information too out of NQE.
yes, yeah, let's take a look, right? So when I say we collect the ARP table, we not only collect the raw data from your devices using a show command. Once we collect that ARP table from all your devices, we actually normalize it by making them look the same. Now, when you think about ARP table output from a Cisco device versus a ARP table output, let's say from a Palo Alto firewall, they look completely different on the CLI. But
Oh yeah.
what Forward has done is done the hard work of making them look the same before we store them in the Forward database, right? So when you use NQE, the database query language, to look for that ARP table information, they're all very consistent, regardless of what kind of vendor we learn that information from. So
Interesting.
yeah, so let's take a look, right? So we have the data model, which will tell you what data we have available for each of the devices. And I'm
Mhm.
just scrolling down until I find the hosts, right? So the hosts is a list of all the ARP entries we learn from that individual device. So our goal here is to iterate through every single device in your network, look through all the ARP table entries for each device, and look for MAC addresses that has the vendor code Huawei in it, right?
Okay.
And of course, NQE is a domain specific language, and we've done a lot of work trying to help you so you don't have to go through the process of writing them from the scratch. So what we're looking for here is the host, and under the host, we're looking for MAC addresses. And when I click on it, it actually tells me, here's an example to help you get started, right? So here is what the language looks like. It's very
Mhm.
similar to SQL. And I actually have a template set up for you. Let me paste that to the text editor to the left. So we can get rid of this data language right here.
Mhm.
So these lines, line 7 through line 19, there are not that many lines here, but what this is doing is iterating through every single device in the network. And for every device, we're enumerating the MAC addresses we learned in the ARP table. So let me click on execute. You have about 117 ARP entries in your network.
That
And
returned really quick. Is that typical for it to return as quickly
well,
as
you
it
have a
did?
very small network, right?
Okay.
But in a very large network, I would say, time will increase, but nothing you
Hmm.
can't get out around a minute or two. So it
Okay.
has been optimized for speed. So let's look at what kind of information we're getting, right? So we have your device name. This is the device in which we are iterating through at the moment. We have the
Mhm.
device interface. That's where we learn that particular MAC address from. We have the address of the ARP entry, and we have the MAC address itself. And from the MAC address, we're actually telling you based on the MAC OUI ID, what is the vendor of that MAC address, right? So
Okay.
we've got some Aris devices, we've got some Cisco devices, and remind me, which vendor are you looking for again?
Huawei.
We're looking for Huawei. Okay. It seems like we have at least a couple of them in this environment. But what I want to do is modify this query a little bit so that it returns the Huawei device automatically. So
So when we do that, Jack, is there a way that anytime we do a collection that it always looks for that and I somehow get alerted if it finds one of these devices?
excellent question. Yes, there is. So the way NQE works is that once you have written a query, we can attach it to the collection and processing of the NQE of the forward enterprise whenever it collects data from the network. So every
Okay.
time we collect the data from the network, we will run this query, and you can actually set a condition so that whenever we do identify Huawei devices, we will warn somebody about it. So that process is called setting up a violation condition, right? So
Hmm.
I like to call it is the naughty list. Do you want to be on the naughty list or not? So violation, the way you set it up is you add a new column in the select statement, say violation, right? So
Hmm.
violation needs to be a Boolean. So it's either true or false. So in our case, we want to know if the vendor is Huawei or not
Hmm.
Huawei, right? So the easiest way to do this is I would do a text match, right? So matches is a built-in function that can compare two strings, right? So the first string I want to compare is the vendor from which the MAC address is identified by, right?
Hmm.
So the vendor in this case, this will be the string that will be input into the match function. And the second string, what I want to do is just Huawei, the string Huawei. So this
Okay.
will compare my vendor against this string right here that says Huawei star. And if that matches is true, then violation as a consequence will also be true. Then once we set that condition up, NQE will automatically process. And if it identify any Huawei true violations, then someone will be warned.
Okay.
Okay, so let's run this updated NQE query. Right, you see, we added a new violation column, but nothing really changes. But what I can do is over here, I can filter for true.
Hmm.
So violation equal to true whenever we do identify a Huawei device.
That's awesome. So you were talking about that we can get alerted if anything is shown in a violation of true. What
Absolutely.
manners can I, as the network guy, or I, as a cybersecurity guy, be alerted that there are rogue devices inside of the network that we're actually looking for?
Well, the easiest way to do this is an email. If you set up
Okay.
an email, we can warn you about it. We also have a push notification in which you can
Hmm.
use to set up with your monitoring solution like Splunk and
Okay.
push the violation equal to true entries into Splunk, and you can be warned from there.
Awesome. Do we also tie could this also be tied into ServiceNow? So incident tickets could be created too?
Absolutely. Yeah, once you set up to ServiceNow, you can set up a condition in which all the data we collected here are sent to ServiceNow as the payload of the ticket. And an engineer who's responsible for remediating these devices will have all the information ready to go whenever they receive a ticket.
That's awesome. I remember back in the day having to find devices. Like it was like pretty much trying to find a needle in like the haystack, right? The security
Yeah,
team would get
imagine.
an alert
Mhm.
and they'd say, "Hey, where does this live?" So now we know the switch, we know the port, right? What other like information, like could we click like the device name and actually see how we're building?
Ah, I like the way you think. Trust but
Mm,
verify. Right?
yes.
So let's see. This one device right here is with this name on it, and it's
Mhm.
connected on Ethernet 4, has IP address of 10.1.1.15.2. So let's remember all this information and see if we can find this in the actual output for the ARP entry for this device. So let me click on this device right here. This is an Arista device, and it's somewhere in Atlanta data center, right? So let's take a look at the device state in
Mhm.
which all the show command data stores, right? So we have ARP, we have RPVRF. Let's take a look at ARP for now. Okay, so there's nothing in the default ARP table. So let's look at ARP VRF. Now we're getting something right here. So remember the IP address I said, remember? 10.1.1.15.2
Yep.
with this MAC address and this interface on that device. So
Wow.
looks like NQE has parsed this information and it is storing it in a key value format and is ready to go wherever you run this query. So
That's
here,
awesome.
here.
I could see this saving so much time, especially if you're in a massive environment and you always want to try to audit to make sure that you don't have any contractors plugging stuff into ports that they shouldn't be plugging into, or any devices that really shouldn't be inside of the network that really have no merit of being there, that they're like against company policy or a standard use. This is great, Jack. This is great stuff, especially around the holidays when like network and security guys want to spend time with their families. The last things they want to do is be on a trouble bridge trying to find, like I said before, that proverbial needle in a haystack. This is awesome
Exactly.
stuff.
Yeah, you hit the point right. Yeah, you hit a big point right here is that this will be very, very useful in a massive network where it is just impossible to find information. We have a small network here. It's very
Mm,
easy to take interface by interface until you find something. But imagine you have 40, 50,000, 100,000 devices in your network. Consider how many ARP entries you are dealing with. This is a very, very big help for people who
yeah.
are identifying a specific set of devices.
No, that's awesome. Jack, amazing stuff. This is truly, truly, truly amazing to look at and to see how quickly and with, it was like easy. If like you didn't know what you were looking for, the data model, you can very easily search it, get what you want, and then kind of modify and massage as you want. Fantastic, man. Appreciate it.
Of course.
All right. Let's see if we have any questions. This is always the fun part.
Yeah. Let's see.
All right. I then I swear the next one I'm going to get the Jeopardy music. If we can play the Jeopardy music, I don't know how if that's copyrighted or not. All right. I think bad singing doesn't count, so I think we can do that.
Oh, uh-oh.
All right. No questions. All right. So we're gonna say that if you watch this, like on demand, or if you have any questions after the fact, definitely ask them. Jack or I constantly monitor, so we'll go back and look and like answer the questions. Again, Jack, thank you very much for joining me on this festive Demo Tuesday, and to all of our Demo Tuesday watchers out there, have a great, happy, and healthy holiday, and have a fantastic and safe new year. Thank you very much.
Happy holidays, everyone.